Now let me use experiment 1 as an example to explain how to conduct error analysis. When we conduct error analysis, we want to know whether a particular source of error contributes to the observed experiment error. It can be done qualitatively. It can also be done quantitatively. It will be carried out in 2 steps. The first step is if the source of error is the reason that caused the experimental error. Are we going to get positive error or negative error? Then, does the predicted error match the experimental error? For example, if our error analysis tells us that we are going to get positive error, then we compare to the observed experimental error. If the observed experimental error is positive, that means our error analysis makes sense. Otherwise, we have to find a different source of error. Quantitatively, what percentage of error are we going to expect? Then, does the expected percentage error match the observed experimental error? If it does, yes, this is the possible source of error. Otherwise, we have to look for different source of errors. From the first experiment, we used water as the calibration material to calibrate the volume reading at different marks. Then we use the calibrated volume at the mark to determine the density of the unknown liquid. A common source of error is we may have water droplets on the wall. This is very common. Then if we don't remove the water droplets on the wall, is this the possible source of error that contributes or that can explain the observed experimental error? Let's look at the details. When we use water to calibrate the mark reading at this 2 milliliter mark, we use the mass of water over the density of water. The density of water can be looked up from a table. The mass of water is from the electronic balance measurement. Since we have water droplets on the wall of the gradient cylinder, therefore, the mass of water will be larger than without the water droplets on the wall. During this calculation, the volume of water should be larger than the volume reading at the mark. Let me put this down. When we calculate the density of the unknown liquid, we use the mass of the unknown liquid divided by the volume of water. In reality, the true density of the unknown liquid is equal to the mass of the unknown liquid over the volume at the mark. Since the volume of water from the calibration is larger than the volume at the mark, the same number divided by a larger number will make this number smaller than this number. Therefore, if we have water droplets on the wall when we conduct calibration of the gradient cylinder, the density we calculated will be smaller than the true density of the unknown liquid. From our analysis, the calculated density of the unknown liquid should be smaller than the true density of the unknown liquid. Then we compare with the observed experimental error. Say if this is the case. If we do see that the calculated density is smaller than the density of the unknown liquid from the literature, then the water droplets on the wall during the calibration of the gradient cylinder is the possible source of error. We can also conduct quantitative error analysis. Let me show that. If we assume the volume of the water droplets on the wall during the calibration is 0.06 milliliter. 0.06 milliliter is the average volume of a water droplet. Then, when we calibrate the 2 milliliter mark, the percentage of error will be about 3%. Apparently, when we calibrate a different mark, for example at 4 milliliter, if we still have one water droplet on the wall of the gradient cylinder, then the percentage of error will be smaller. And then we can compare the calculated density of the unknown liquid to the true density of the unknown liquid. Remember, the true density of the unknown liquid can be from literature, can be from other trustable sources. Then, if it is about 3%, then the water droplets on the wall of the gradient cylinder during the calibration is the source of error. But if the observed experimental error is larger than 3%, at least the water droplets on the wall of the gradient cylinder is not the only source of error. We have to look for the other possible source of errors. But if the observed experimental error is less than 3%, that indicates possibly it is not the source of error. We have to look for a different source of error. You can also analyze if there are water droplets on the wall of the gradient cylinder during the determination of the density of the unknown liquid. You can compare those. Then you will get a different conclusion. I think I showed you an example to explain what is meaningful error analysis, both qualitatively and quantitatively. Hopefully you can get something from me.